Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at Form 3 Chemistry, and the topic for today is the mole. So we are going to progress with our previous video when we were discussing on empirical formula. So today we are going to finish up with the molecular formula, and then we'll do a few questions. So the molecular formula is usually shows the actual number of each kind of atoms present in a molecule or a compound. So the empirical formula of an ionic compound is the same as the chemical formula, but for simpler molecular structured compound, the empirical formula may not be the same as the chemical formula. So you might see that distinction. The molecular formula is a multiple of empirical formula, and it is usually determined by this method. So you take the relative empirical formula multiplied by n, where n is a whole number, is equals to relative formula mass, or the relative molecular mass. So this is the formula we are going to be using. We will find out the empirical formula in the same manner we did in the previous video. But when we get now to the final answer, we will use the relative formula mass to get the molecular mass. So this is what we mean. Let's do a few questions. So an hydrocarbon was found to contain 92.3% carbon. So we start with carbon, and the mass is 92.3%. And then the remaining is hydrogen. So you say 100 minus 92.3, which gives us 7.7. So for the hydrogen is 7.7%. Next, the atomic masses of carbon is 12, for hydrogen is 1. So if we were to calculate the moles, we'll say it's the mass, which is 92.3, divided by the atomic mass, which is 12. And the same case with hydrogen, 7.7 divided by 1. So 92.3 divided by 12 will give us 7.692, while 7.7 divided by 1 is 7.7. So we get the two ratios, which is 7.692. We do the more ratios, 7.7. We take the least, which is 7.692 divided by 7.692. This gives us 1, and then this will give us 1.0010. So this is the same as the ratio of 1:1. So now this gives us the empirical formula of CH. So we are not done. So you have been told the molecular mass of compound is 78. Determine the molecular mass. So we said it is the empirical formula. You multiply by n is equals to the relative formula mass. So the empirical formula times n, when you look at the atomic masses of carbon, you take the specific is 12 plus 1, then times n is equals to relative formula mass or molecular mass you've been given is 78. So this tells us this is 13, n is equals to 78. You divide by 13, you divide by 13, you get the value of n to be 6. So if we go back, we said it is CH into bracket n, and you already have the n, so it is CH into bracket 6, which gives us C6H6. So this is our answer. Let's do another question. A compound of carbon, hydrogen, and oxygen contains 54.55% of carbon, 9.01, and the remaining 36.36 of oxygen. So this 9.01 is for the hydrogen. So let's put that down. So we have carbon, hydrogen, and oxygen. So let's use this table instead. So the mass of carbon is 54.55. The mass of hydrogen is 9.09. And then the mass of oxygen is 36.36. The atomic mass of carbon is 12, the atomic mass of hydrogen is 1, and the atomic mass of oxygen is 16. So if you were to calculate the number of moles, it would be 54.55 divided by 12, and then 9.09 divided by 1, and 36.36 divided by 16. So 54.55 divided by 12 will give 4.546, and then 9.09 divided by 1 will give us 9.09, and then 36.36 divided by 16 will give us 2.273. So you divide all the sides, remember in the moles, by the list, and the list is 2.273. So you divide by 2.273, you divide by 2.273, and you divide by 2.273. So this gives us 1. This one will give us 3.999, and then 4.546 divided by 2.273 will give us 2. So this is the same as 2 is to 4. Remember, you can round off because it's, if you round this to whole number, it's going to be 4, and it's possible because you can see it's 0.9 and then 1. So when you write the empirical formula, it's going to be C2H40. So next, we are not done. We have been given the molecular mass 88. So we will take the relative, the empirical formula, which is C2H50. You put in a bracket and you put an N is equals to molecular mass, which is 88. So if you look at the atomic masses in the empirical formula, this is going to be 12 times 2 plus 1 times 5 times 4. This is supposed to be 4. C4, H4. And then times 16 plus 16. N is equals to 88. So this is the same as 24 plus 4 plus 16, which gives us 44 into bracket. N is equals to 88. Divide by 44, divide by 44. So the value of N is 2. So you go back to your empirical formula, which was C2H4 O into bracket N. Now it's going to be C2H4O into bracket 2. So if you open the bracket, it's going to be C4H8O2. This is going to be our answer. Let's do another question. Hydrocarbon burns completely in air to form 8.28 grams of carbon dioxide and 2.16 grams of water. If the molecular mass of hydrocarbon is 84, determine its molecular formula. So we did a similar question in the previous video. So carbon, hydrogen. So carbon is going to be derived from carbon dioxide. So carbon is 12 over the total mass of carbon dioxide, which is 44, times the mass of carbon dioxide is 5.28, which will give us 1.44. And then hydrogen, the same, is going to be 2. There are 2 because in the formula of water is H20, oh, not 0. So we have 2 atoms of hydrogen, that's why we are putting 2, not 1. Divide by the total mass of water, which is 18, times the mass of the water was 2.16 grams. So basically, we want to get the amount of mass of hydrogen in the water. So this will give us 0.24. And remember, this is the mass. So the atomic mass of carbon is 12 and the atomic mass of hydrogen is 1. So if we were to calculate the number of moles, it will be 1.44 divided by 12 and then 0.24 divided by 1. So 1.44 divided by 12 will give us 0.1 1, 2, and 0.4 divided by 1 will give us 0.24. So we divide by the lowest value, which is 0.12. So 0.12, 0.12, this will give us 1, and then 2. So the ratio is 1:2, so the empirical formula is going to be CH2. So we are not done, so the empirical formula is CH2 into bracket N is equals to the molecular mass of the hydrocarbon, which is 84. So if you look at the values inside, the atomic number of carbon is 12 plus 1 times 2 into bracket N is equals to 84. This gives us 12 plus 2 into bracket 84, which is the same as 14N is equals to 84. We divide by 14, divide by 14, get the value of N as 6. So the molecular formula is going to be the empirical formula multiplied by 6 because our N is 6. So this gives us C6H12, which is our final answer. So I hope you have been able to connect the empirical formula and the molecular formula, and you can be able to do the calculation comfortably. So see you in the next lesson.